Hello, welcome back. This is chapter 1.4. In this section, we're going to be rewriting formulas and equations. So by the end of this, you should be able to solve for a given variable in an equation with multiple variables. You'll also be able to rewrite a linear equation. And what we mean by that is might be given equations with multiple variables inside, something like this. Notice that there's an x and a y. In the previous section, there was a single variable. We were getting one variable by itself. In this section, we're going to be taking equations with multiple variables inside or a formula and learning how to get a variable by itself still. So let's go ahead and look at our first couple of examples here. Now, the main thing with solving formulas is that the rules are the same. We are still solving for a variable. We are still trying to isolate that variable. We are still doing so by doing opposite operations. So let's look at this first example right here. And what we want to do for this example is solve for r. Okay? So that means that this is the variable right here that I'm trying to get by itself. Now, notice that this is all multiplication happening here. This is 2 times pi times r. So I need to do the opposite operation in order to eliminate this 2 pi. Because all of this is being multiplied together, I can divide by 2 pi to cancel it out. Dividing by 2 pi cancels the 2's. Dividing by 2 pi cancels the pi. Now, because I did that on the right-hand side of the equation, I also have to do it to the left-hand side of the equation. So on the left-hand side, notice that on the left-hand side there isn't things that are combinable, right? C divided by 2 is just C divided by 2. C divided by pi is just C divided by pi. There's no operations that can be done here. So on the left-hand side, we simply have that, C divided by 2 pi. Because we can't divide these to find some other specific value, so we just write what the operation was. And on the left-hand side, well, we canceled everything out. We've got the r by itself, so there it is. This is this formula solved for r. By the way, if you didn't know, this formula over here, it is the perimeter formula, perimeter of a circle. 2 pi r, right? 2 times the radius or the diameter times pi. So, same rules. Like, that's the key. Same rules. We're doing the opposite operation. The only part that's funny or a little bit different is how we look at these operations on the other side. But because there's nothing that can be combined here, there's no operations that change the value, or that we can see a value change there. It looks like that. It looks like the operation we did. Let's do this example over here. We have d equals 2 times a divided by the square root of 3. And what we're going to do over here is solve for a. Now, you got a fraction looking thing there. Don't freak out. Okay? With these types of problems, we're trying to get the a by itself. Remember, fraction bars are division. So we're going to undo that with the opposite of division. We're going to multiply. So on the right-hand side, we're going to multiply by the square root of 3. And remember, that's the square root of 3 over 1. So those cancel that out. So on the right-hand side, we end up with 2a, because when we're dividing by root 3, we multiply by root 3 to undo it. Because we did that on the right, we have to do that on the left. So we're going to multiply d by root 3. And as it turns out, when d times root 3, there isn't a meaningful way to do the operation on that. So it's simply d root 3. And notice that I put the d in front, just because typically when we're multiplying something by a root, we put whatever we're multiplying in front of the root. But this is still d times root 3. And now we know what we got to do over here. This is 2 times a. We're going to divide by 2. I'm going to divide by 2 over here. On the right-hand side, we have a by itself now. D divided by 2, can't combine those. Root 3 divided by root 2, can't combine those. So our final answer is d root 3 over 2. Again, most of the time when we're solving, if we're working with different variables like this, the operations won't combine in a meaningful way. So we just write what the operation is. So this is solving a formula. Let's look at solving something with 3 different variables here. So this is the formula for perimeter of a rectangle. This is perimeter of a rectangle. And again, we're going to solve for W. Now, if we're solving for W, it means we're trying to get this W term over here by itself. So this is 2 times L plus 2 times W. The first thing we want to do is just get rid of this whole term. And because this term is separated by addition, we can subtract that term away. And we're going to do the same thing to the other side. 2L minus 2L makes 0, so it cancels. On the left-hand side, we have P minus 2L. Well, these are different terms. There's the P term and the L term. So we can't combine them. So we simply write it out like that, P minus 2L. And then this is 2W. And again, now we need to get the W by itself. So we have 2 times W. Well, I know that I'm going to divide by 2 to make that happen. Over here, I'm going to divide by 2. So on the right-hand side, 2 divided by 2 makes 1, so they cancel. So on the right-hand side, we have just W. On the left-hand side, now there's 2 ways you can report this answer. You can report it as the whole thing divided by 2 and just do it like this. This is sometimes an appropriate answer. The other way to do this is to recognize that the 2 is dividing both of these terms. So it's P over 2 minus 2L over 2 equals W. And then finally, we can do this last bit of simplification. 2 divided by 2 cancels. So final answer would be W equals P over 2 minus L. Notice that, again, the rules aren't changing. We're doing the opposite operation on both sides. The objective is to get the variable by itself. The only thing that's different is how we do the combining like terms and the operations over here. We just have to remember that when things aren't like terms, we can't add or subtract them. When they're different variables, when we multiply 2 different variables, it's just x, y, right? So this is the tough part. How do we do the combining? The steps we should be able to do because they're the same as the previous section. It's the way that we combine these over here that makes this a little bit more complicated. Let's do one more example. This is a linear equation now. We have x and y. We are going to solve for y. This is something that in our next unit, chapter 2, where we're talking about linear equations, that we're going to have to do quite a bit of. So we want to get good at it. Again, I'm solving for this term, this y term. This is being separated through subtraction. It's a different term over here. So I'm going to subtract 9x to get rid of that. 9x minus 9x makes 0. It cancels. I'm going to do the same thing over here. Remember to bring the negative down. Negative 4y equals, and then these are different terms. 7 minus 9x. 7 minus 9x. Now we're going to divide by negative 4, just like we did in the last example. And those cancel. So we have y equals 7 minus 9x over negative 4. Or like I said, you could write it as negative 7/4. That would be plus, because a negative divided by a negative, plus 9/4 x. Either of these are kind of acceptable solutions. Check with your teacher to decide which one they like better, because you might have it one year like this, and then your next teacher the next year is going to say, ah, well, the other ones are No, I'd rather see it this way. So check with your teacher with what they want, okay? But be familiar with both, all right? And that's everything we've got for 1.4. We're going to do some practice in class with these. So don't worry because I know this one's kind of a tough subject. But we'll get on that. Thank you very much for watching, and we'll see you another time.